Hey everybody, it's Mr. Carr again. Today we're going to be looking at 9-3 day one. We're going to be looking at polar coordinates and rectangular coordinates. So that's our focus here. So when we talk about this, we mean our polar coordinates r comma theta and our rectangular coordinates, which is x and y. And so we're looking at how are these things going to be related to each other. And so in that case, we're going to be able to convert back and forth. And so this is our basic setup here. If we have a point P as a polar coordinate made up of r comma theta, then that means that the x and y related to that is going to be that x is equal to r cosine theta and y is equal to r sine theta. And then that means that my format for x and y is going to be set up as r cosine theta comma r sine theta. So that's what we're going to get in terms of converting back and forth between the two. So if I have an r right here at that theta, that's going to be the same as if I basically model as a triangle is what I'm getting at here. So my shortcut is just doing r cosine theta for x and r sine theta for y. So let's take a look at our example here. Find the rectangular coordinates for D2 is at 2 pi 3, pi over 3. So let me first plot that. Here's point D right here. So it's at a radius of 2 and it's at the coordinates of pi over 3. So when I do this, and notice how with pi over 3, I can create a 30, 60, 90 triangle here. So it's going to be 60 degrees that's associated with that. So it's going to be a 1, 2, and root 3. So for x was equal to r times the cosine of theta. Well, r is 2 in this case. So that means x is equal to 2 times the cosine of my theta here, which is going to be 2 times 1/2. So that means x is going to come out as 1. For y is equal to r times the sine of theta. So y is equal to 2 times my sine of my 60, which is root 3 over 2, which comes out to the square root of 3. So that means that when I look at the rectangle coordinates here, my point is going to be 1 comma root 3. That's the point that's associated to point D on a polar graph. So again, this is just looking at 1 comma root 3. It's going to be this point right here on an xy versus my polar position. Okay. So the rest of these are going to basically do the same thing. We're going to start with graphing these and we're going to use our definitions here. So in this case here, we've got -5 at 45 degrees. So 45 degrees puts me here. So -5 is going to go 1, 2, 3, 4, 5 this way. Here's my point F. Okay. So in this case, we can find our, we can actually find this like using our graphing calculators, like you could just plug the certain things in. So notice that I'm at the 225 degrees. So I want to find x, I could do x is equal to 5 times the cosine of 225. And the same thing with y. Y is equal to 5 times the sine of 225. But if I want my exact answers, I'm going to have to model this as a triangle. So the kind of triangle I get would look like this, which is a 45, 45, 90 triangle right here. So that's 1, 1, and root 2. Okay. So what that means in this scenario, remember what is my cosine and sine in this case. If I'm going in this direction, I'm in a third quadrant. Both sine and cosine are negative there. So that means the cosine of my theta in this case is going to be a negative 1 over root 2, or just root 2 over 2. The sine of my theta is also going to be the same thing. It's a negative root 2 over 2, because both sine and cosine are negative there. So that means if I come back here for my coordinates, x is equal to 5 times a negative root 2 over 2, which just comes out to negative 5 root 2 over 2. Y is going to do the same thing. Y is going to come out to a negative 5 root 2 over 2. So as an x and y coordinate for my rectangular coordinates, it is negative 5 root 2 over 2, negative 5 root 2 over 2. So that is the x and y rectangular coordinate that is associated with that same polar coordinate. Okay, so if we want to go from rectangular to polar coordinates, we got to remember these couple facts. Since r, we're basically looking at a unit circle, r is always going to be the square root of x squared plus y squared. Okay, that's where it's coming from, is from a unit circle idea. Tangent of theta, well, since we know from before, tangent of theta is equal to y over x, that means my theta is equal to the inverse tangent of these. And then, because we're on polar coordinates, we can keep in mind that we're going to be adding pi or 180 to get to the other side as well. So let's just take a look at a couple examples of these. So find two pairs of polar coordinates for the point E at 2, -4. So that's going to put me at 2, 1, 2, 3, 4. Right here is point E. Okay, so I'm trying to find what polar coordinate matches with that. So first thing I'm going to do is let's find r. R is equal to the square root of 2 squared plus a negative 4 squared. Okay, so r is equal to the square root of 20, which is equal to 2 root 5. That's when I break it down there. Since I'm working at 0 to 2 pi here, I want to make sure I put everything in terms of radians. So one thing that might be easier, I could put in like my negative numbers here, but it might be easier if I just think of it as I'm going to find this theta prime as my reference angle and then go off of that for figuring out my actual polar coordinates. So what I mean by that is my theta is just equal to the inverse tangent of y over x. So that's going to be, in this case, I'm going to just put it into positives, 4 over 2. Okay. So when I do that and I plug this in my calculator, my theta is going to come out to 1.11. Make sure you're in radian mode because this is going to be 1.11 radians. So that 1.11 radians is referring to, I should do this, theta prime here. It's my reference angle here. But the actual polar coordinate is not going to be that. We want our polar coordinate to be in this specific interval. It has to be a positive. So I can't go officially, this would be a negative 1.11. So that's a negative 1.11. I need to figure out what is my same positive position to get me there. So for me to go all the way there, I'm going to take this. I'm going to take 2 pi minus 1.11. Okay. Or I'm saying negative 1.11. I guess I'm technically doing this is more accurate. I'm taking a negative 1.11 radians and I'm adding 2 pi radians to get my coterminal. When I do that, that comes out to 5.18 radians. So what that means is I have my first polar coordinate. This is going to be this one here will be 2 root 5 and then 5.18 radians. Okay, for my second one, remember, we can also go here. If I go to this position, but then I do a negative radius, that will also get me the same spot there. Well, this is where the plus or minus pi comes in. This spot right here is pi radians, and then this is a negative 1.11. So what that means is I can do negative 1.11 plus pi, and that will tell me my other radian measure there, which is 2.03 radians. Okay, so as a coordinate, that is going to be a negative 2 root 5, and then 2.03. Like that a little bit better. Like that. Okay. One more example to go over with this one. We have g is negative 3, negative 4. Now we're going to put it into degrees. Same process though. So if I start with this one here, negative 3, negative 4 is going to put me 1, 2, 3, 1, 2, 3, 4. Here's point G. So I'm going to find my reference angle to start. Okay, so theta prime here. Well, sorry, I'm going to find my radius r. So r is going to equal to the square root of negative 3 squared plus negative 4 squared. Okay. Sorry about that 1 second here. Hey, get some background music. So if I do that, r is just going to come out to 5. Theta is going to equal to the inverse tangent of y over x. That's going to be the inverse tangent of 4 over 3, which comes out to a reference angle of 53.13 degrees. Now remember, that's what the angle is right here. So I need to figure out where is it at in terms of going all the way around this way. So that is going to equal to 180 plus my 53.13, which gives me 233.13 degrees. So my first polar coordinate is going to be 5, 233.13 degrees. My other one is going to put me out here, where it's 3, 1, 2, 3, 4. Here's the other possibility. Okay, so that angle measure is going to match up to my theta right here. So it's the same as this one. So that's going to be a negative 5 and 53.13 degrees. And that's it. That's all we're working on today. Just making sure we convert back and forth between our polar and rectangular coordinates. We'll continue that on into the next lesson with our polar and rectangular equations. All right, but that's it for today. Take care, everyone.